Good morning, everyone. Graphical representation of motion, part 2. Already we discussed about uh, displacement time graph and velocity time graph. Today we are going to study about. Today we are actually discussing two topics. One is acceleration time graph and bouncing ball. So bouncing ball, different graphs related to the bouncing ball. These are the things we are going to study today. So first, acceleration time graph. Acceleration time graph. What is actually acceleration means? Acceleration means the rate of change of velocity. If there is a change in velocity, we can say that there will be an acceleration. If the change is like if velocity increases means we call it as acceleration or positive acceleration. If velocity decreases means we call it as deceleration or negative acceleration. So acceleration is the rate of change of velocity. So when we go to the acceleration time graph, we have two axes, x-axis and y-axis. Y-axis we will plot the acceleration and x-axis we will plot time. So there are different acceleration time graphs are there. So we can discuss what are the different acceleration time graph. So here, so we are discussing four situations. The first one is rest. Rest means the object is not moving, means the speed or velocity is equal to zero and acceleration is also zero. Uniform motion. For in uniform motion, velocity is constant. If velocity is constant, acceleration will be zero. Third situation, accelerated motion. Accelerated motion means I said velocity increases and acceleration is a positive constant. You remember we are discussing about uniformly accelerated motion. That's what I wrote. Acceleration is a constant, positive constant. Positive means the velocity increases or it is accelerating. The fourth situation, decelerated motion, means uniformly decelerated motion. So here, what happened to the velocity? Velocity decreases, and acceleration is a negative constant. Negative is due to velocity decrease, and it's constant because it's uniformly decelerating. Okay, so these are the four situations we are going to study. Oh, we just discuss about that. So we can see how the acceleration time graphs looks like for these four situations. So the first one, rest. Rest means we know acceleration is zero, so it should be on the same horizontal axis, x-axis. Second one, uniform motion. In the case of uniform motion also, acceleration is zero. If acceleration is zero, the graph will be like that. Next is uniformly accelerated motion. Third one is uniformly accelerated motion. Means acceleration is a positive constant. So no gradient will be there. So we can see that. And fourth one, decelerated motion means uniformly decelerated motion. In uniform decelerated motion, acceleration is constant but in negative side. So that's what we wrote. We drew that in the negative side. So these are the four graphs for acceleration time graph. Okay. So rest, uniform motion, accelerated motion, decelerated motion. Okay. So these are the things you have to study about acceleration time graph. So now we can just compare displacement time graph, velocity time graph, acceleration time graph in different situations. Okay, so let's move to the next topic, comparison. So, graphical comparison between displacement, velocity, and acceleration. So, look at the first row. Stationary object means the object is at rest. So, first one shows a displacement time graph, velocity time graph, acceleration time graph. So, look at the graphs now. Rest means we know there is no speed, so the gradient is zero. So for velocity time, there is no speed or there is no velocity, so it should be on the x-axis, and acceleration is also same. Then uniform motion, the speed is constant. If the speed is constant, for displacement time graph, the gradient will be a constant, positive constant. So it is showing like that, exactly like that. Then velocity time graph, for uniform motion, velocity is constant, so it should be horizontal straight line. Acceleration time graph, uniform motion, acceleration is zero, so it should be on the zero axis, horizontal line on zero axis or x axis. Then motion with the constant acceleration means there will be an acceleration, means displacement time graph, it's a curved graph. The curve represents there is an acceleration, the gradient is increasing, means velocity is increasing in displacement time graph. Constant acceleration means velocity increases constantly, means there will be an acceleration but the acceleration is constant, means in velocity time graph the gradient is constant. So look at the graph, we can see the gradient is constant. The third one, acceleration time graph, obviously acceleration is constant. So acceleration is constant means it should be a straight line, horizontal straight line, non-zero straight line. Okay, so these are the comparison. We can compare the displacement, means sometimes in the exam they will ask what will be the corresponding velocity time graph or acceleration time graph. They will give displacement time graph. So sometimes they will give a velocity time graph and we have to draw a corresponding acceleration time graph or displacement time graph. So those questions, this slide is very useful. So please compare the graphs. Okay. Then now we are going to study about the our next topic, bouncing ball. Bouncing ball. So what is in upward motion, decelerate, it's a decelerated motion, means the velocity decrease. Then the deceleration is constant, means acceleration is constant but negative. Then A is equal to minus G, which is equal to minus 9.81 meter per second square. Again, at maximum height, when you reach at maximum height, velocity will be zero. Then when it bounces from the ground, its velocity will be maximum. So these are things, the technical terms. So technically what is happening during upward motion and downward motion, this is what you have to remember. Then very important thing, when we are going to draw a graph for bouncing ball, means displacement time graph, velocity time graph, acceleration time graph for bouncing ball. So before drawing the graph we should have to know some important point. So let's see important points to remember. You know, the displacement, velocity and accelerations are vector quantity. We know vector quantity means it has both the magnitude and direction. So the direction is very important. Then, when a ball bounces, means in bouncing ball, the ball we already discussed, the ball moving in two directions, upward and downward. It is moving up and it's moving down continuously. Okay, so here we consider upward motion is in positive direction, means upward motion we take it is positive direction, and downward motion we take it as negative direction. So positive direction and negative directions are there, which means that in bouncing ball the object is moving, or the ball is moving in two different direction, exactly opposite. So we should have to consider one direction positive and another direction negative. In this case, we consider the upward motion is positive and downward motion is negative. Okay. Then next, the graphs. How the displacement time graph, velocity time graph, acceleration time graph looks for our bouncing ball. So there are two cases are there. Some cases there will not be any delay, no delay. So motion of bouncing ball without any time delay. Time delay means when it hit the ground. Sometimes some balls will take some time to bounce once it is incident on the ground. So some ball it will rebounces back without any time delay. So if there is no time delay means how the displacement, velocity and acceleration time graphs looks like. So these are the graphs. First one, displacement time graph. Second one, velocity time graph, and third one, acceleration time graph. Why the displacement time graph is like that? Why velocity time graph is like that? Why acceleration time graph? Acceleration time graph only in negative side. Why? Displacement only in positive side. Velocity both the positive side and negative side, and acceleration only in negative side. And also it's an horizontal, a straight line in negative side. Why each graph exactly looks like that? So first, we can analyze the displacement time graph for a bouncing ball. So, displacement time graph of bouncing ball. Here, here, look at the graph. Why the graph is exactly like this? We are dropping. So look at the graph, the initially the displacement is maximum. We can see the displacement is maximum at first, which means that we are dropping the object from certain height. So we are dropping an object from certain height, so there will be some height, so the displacement is maximum. So we drop the object is moving down. So when the object moves down, it's a negative direction, so negative gradient should be there. That's why it's moving down, and it is accelerating. You can see there the gradient is increasing. Gradient increases means it is accelerating. So you can see the first dotted line. At that point, what the ball reaches the ground. When the ball reaches the ground, it rebounds back. So when it rebounds back, it is accelerated motion. Accelerated motion means we can see it's a positive gradient, and uh, the gradient is decreasing, means it is decelerated motion. Once again, it is decelerated. There will be an acceleration, but acceleration is negative, that is deceleration. Okay, so at the top the velocity is 0, then again it's moving back. So when it is moving back, it is accelerated motion. So again what happened, it is moving down, so it hit the ground again, so displacement is zero and it continues. So here we can see each time the height is different, means it loses some of its energy, so the height will be decreased. Okay, so this is how the displacement time graph looks like this. So once again, zero displacement means it's a ground, it's a flow. Then the gradient of the displacement time graph is velocity. At first what is happening? At first the gradient of the graph is negative and increases. When the ball hits the ground, it bounces back up and the gradient become positive. That's what we said. When it bounces back, the gradient is positive. But the gradient is then decreases until the ball is at the top of its path, that is at the center of each loop. Okay, so this is how the displacement time graph of bouncing ball exactly looks like this. Now velocity time graph of bouncing ball. So look at the graph, it's a starting in negative side. When we drop the object, the initial velocity is zero. That's why initially it's zero. Now it's falling. When it is falling, it accelerate. Okay, and it hit the ground with the highest velocity. Then it bounces back. Bounces back means it's a positive motion, so we have to draw the bouncing back means upward motion in positive sides. That's why it's moved to the positive side. Then very important thing you have to remember, the rebounding speed less than the colliding speed. For example, if a ball incident on the ground with 20 meter per second, it rebounds from the ground maybe with 19 meter per second, means there will be some velocity drop. Then, and also one more thing you have to remember, when it bounces back with the 19 meter per second, means next time it hit the ground it should be 19 meter per second. Means speed at which ball falls back on the floor must be the same as the speed after rebounding the ball. Means bouncing speed and falling speed must be the same. Okay, then why it's a same gradient, the slope is exactly same for everywhere, because velocity time graph, the gradient is acceleration, the acceleration is constant, 9.81 meter per second square. That's why the gradient is constant. And rising time and falling time must be the same, means the time taken to rise and time taken to fall should be the same. Okay, that you have to remember. Then this is about velocity time graph. The next one is acceleration time graph of bouncing ball. So acceleration time graph, here in acceleration time graph, acceleration is constant, means bouncing ball, during a bouncing ball the acceleration is constant throughout the motion, the acceleration is 9.81 meter per second square, so acceleration is constant. Then why we drew it everything on the negative side? That's what we can. So when the ball moves up, the acceleration is constant and it's negative, means it's deceleration, right? Once again, when the ball moves up, the acceleration is constant and it is negative because it decelerate. So that's why we are drawing at in the negative side. Then when the ball moves down, acceleration is constant and positive, but the direction of motion is negative. We already said when the ball is moving down, the downward motion we considered as negative. So the moving back also we are drawing on the negative side. So we are continuous this. So when we continue this, what happened? We are drawing in the negative side. Okay, so this is why the acceleration time graph it's a it's constant and it's always we draw in the negative part of the graph. Okay, so this is what we have to study about bouncing ball graph if there is no time delay. So the first one is displacement time graph, then velocity time graph, then acceleration time graph. Okay. Next, motion of a bouncing ball with time delay. If there is a time delay, what will happen? So look at the graph. You can see that time interval. So in that time interval, there is a small gap. So means it is taking some time. The ball takes some time to bounce. So there will be that much gap. Okay, so please look at the graph. So these are things we have to study about bouncing ball. So very important, the bouncing ball with time delay and without time delay, the graphs are very important. And there are three graphs already we said. One is displacement time graph, then velocity time graph, and acceleration time graph. So this is what we discussed today. So, what we learned today? We learned about acceleration time graph and bouncing ball graphs. Hope you understand. And if you have any doubt, you can contact at any time. And there are two follow-up activities. Assignment 3 and assignment 4. Assignment 1 and 2 already given and the deadline is also over. So next is assignment 3 and assignment 4. The deadline or due date will be announced through Iber group. So you just follow. Okay. Please complete the work on time and submit. Okay. Then thank you very much.